Welcome back to the morning show. It is Wise Guy Wednesday, and we're dealing with the physics of sound today.
Yes.
Matt Selen here. Thanks for joining us.
Sound is fascinating stuff, and what I want to do is, in 2 weeks when I'm back, we're going to break a glass with sound. And it's that classic experiment where...
You're going to sing an opera for us?
No, well, maybe Rob will. We'll see. Well, we may use a little speaker or something.
Okay.
But anyways, you can do that, and sound is fascinating because you don't really, a lot of people don't quite understand how quite it works. And so let me make a point, first of all, how sound actually travels through the air. It travels through the air. It needs air to go. If you were out in space and we were trying to have a conversation, you wouldn't hear anything.
Okay.
The way it works is that the air in this room is at a certain pressure, you know, normal pressure, and when your vocal cords vibrate, they kind of move back and forth a little bit. And if you imagine that the loops of the spring are just molecules in the air, and my finger vibrating back and forth is my vocal cords, you can sort of see that as I wiggle it over here, this little disturbance moves over to this side, okay?
Right.
And so the whole slinky didn't move, but the disturbance moved along the slinky. So just when I talk, I don't make a bunch of air blow into your face, hopefully, unless I'm kind of rude. But what happens is the vibrations travel through the air and go from, you know, my voice box to your ear. So vibrations are kind of the key, and that's how sound gets started. So I realized there's a way you can show this. This was pretty cool. So I took apart my stereo yesterday, and you probably shouldn't do this at home, kids, unless you have an old thing that your mom and dad don't really need. But what I did was I took one of the speaker covers off, and I put a mirror on there.
Okay.
And when you turn on one of these things, oops, and you, now by the way, this music, I don't know what it is because it's my kids. So hopefully it's nothing too bad. Okay. Okay, so anyways, when there's sound that comes out of this thing, it makes the speaker vibrate, and that makes the air vibrate, and it makes the sound go from the speaker to your ear. And so you can see the speaker vibration by basically shining a laser off that little mirror.
Oh.
So what I'm going to do is I'm going to stand over here. I'm going to get out the laser, which is in my pocket.
Okay.
I'm just going to shine it. So this is a pretty bright green laser. If I shine it over there, you can see it.
Right.
Okay. If I shine it over here on the mirror to see if I can get it so that you can see it, so it's on your face.
Oh, my face?
No, it's not. I want it on your face. Okay. So let me turn up the music a little bit. Do you see it there?
Yeah.
Okay. I'm not going to move it, but you can. There we go. See it?
Yeah.
So this is an experiment you can do at home. It's kind of cute. Oops. There we go. So you get that kind of a figure, and you get sort of a pretty shape that the laser will make as the mirror on this thing moves back and forth. I'm going to shut that up because I don't really know who that is, but anyway.
Sure.
So the mirror vibrates a little bit because the speaker was vibrating, the laser beam shines on it, and since the angle of the mirror changes slightly, you see that kind of cute figure. And if you set this up a little more carefully, you can put this on a clamp. This is just a laser pointer you could get, you know, at the store. You can actually see the music. It's kind of neat.
Oh, neat.
Okay, so another way
people say they can hear in color, so we hear in green? No.
Yes, yes, right, exactly. And if you get a cheaper laser pointer, you can hear in red.
Okay.
So, okay, and so if we have just a second, I want to illustrate how this instrument works. So usually then the way that we talk is our voice box vibrates and you make sound. Anything else like a musical instrument that vibrates, it also makes interesting sounds. So this thing makes a very neat sound. It's kind of pretty. And these things are just little metal bars that are laying on these little foamy things. And what's kind of interesting is that if this thing is sitting on top of a wooden base, this thing is necessary. It's like the body of a guitar. It causes resonances. It sort of lets the sound build up.
There's a little hole under there.
If I cover that hole, you don't hear anything. If I pull that out again, you can hear it.
It's still vibrating.
Okay. So it's necessary that the sound go into this thing and sort of resonate and bounce back and forth.
We're about out of time now. What are we going to do when we come back?
When we come back, we're actually going to measure the speed of sound in air and in helium. We're going to understand the differences between those based on the mass of helium versus the mass of air.
Okay.
So it's very scientific. We're going to do some math.
Very interesting. Matt Selen, our wise guy, U of I physics professor.